Ahmed part 2 क्यों ही दीदी?
Can you see the screen, my board?
Yes, sir.
Yes, sir.
Yes, sir.
Very good. Now keep your mic off. Please keep your mic off. So, what we were talking about yesterday, power set of a set, right? And the power set is a subset of all subsets of given set. So, so yesterday we defined, suppose A is a set, right? Then power set of A is denoted by this notation EA, right? And what is it? So subsets such that B is subset of A. All subsets, all those sets which are subsets of A, right? Or set of all subsets of A. And also we saw some examples, and then we were interested in count the number of elements in a power set. Fine. So if cardinality of A is equal to n, then cardinality of power set of A is
2 to the power n.
2 to the power n. This you need to prove. Right. So this is true for each n in n. So for every natural number n, it is true. Means what? You choose set of n elements, then its power set has 2 raised to n elements. So for every n, this is true. And so while proving this, we can use induction. So we shall use, because we want to prove that it is true for every natural number n, means whatever number of elements in A, accordingly we have elements in power set of A. So we shall use induction.
किती ना बापरे. Thanks.
Right, so we want to use induction on n, right? So induction on n, because the number of elements in set, on that we want to use induction. Well, so suppose A, cardinality of A is equal to n. Suppose A has n elements, that is A contains, please keep your mic off, n elements. Somebody have kept mic on, so please don't forget to keep your mic off. It creates disturbance, right? So let suppose A has n elements, that means A has some elements. So what are elements? Doesn't matter. Suppose first element is A1, second element is A2, third element is A3, then nth element is AN, right? So actually here we can avoid induction also. Directly we can prove. We can use induction also. We can use induction, but without induction also we can directly prove it for n elements, right? So induction is another way, but we can use induction, that you think about it later on. But without induction, suppose I take n element set, then what happens immediately, right? Okay, so okay, let us say use induction, don't keep it is. So okay, let us prove by induction directly, then we'll see another method later on. Okay, so suppose it has n elements, then Okay, so what is the first step? What is the first
N is
step?
equals to 1.
So proof for n is equal to 1, best case, right? So if cardinality of A is equal to 1, that means A has only one element, right? Single element, whatever. So I am not interested in what are elements in set A. I am interested in how many elements in A, right? Remember, the set A may contain mangoes or apples or people or city, whatever. I am not interested in the objects. I am interested in how many objects. So then cardinality of A is 1, and what is the power set of A? As we saw yesterday, empty set and set itself. So therefore the cardinality of power set of A is 2, which is 2 raised to 1, that is 2 raised to n. N is in this case 1. Fine. So assume that. So second step, step 2. Somebody have kept mic on, please keep it off. Assume that the statement is true for, so keep your mic off. See, you should understand that it creates disturbances. So immediately you should keep your mic off, because otherwise I have to mute all and then it takes some time. So assume that the statement is true for n is equal to k. That is, if cardinality of A is equal to k, then cardinality of power set of A is 2 raised to k. That is clear to see. So that is anyway. Now what is third step? Inductive step. So that is let cardinality of A is equal to k plus 1. Right. So let. So we are assuming that set has k plus elements. Suppose objects of set A are A1, A2, A3, AK, and next object is AK plus 1. Suppose these are objects in set A. So now let B is equal to A1, A2, AK. I will separate this B. Then I can say that A is equal to B union AK plus 1. I can say that A is equal to B union. I will separate out K elements, and then I will separate out AK plus 1 from these K elements. So certainly I can say that set A is B union this single element, right? Fine. So note that cardinality of B is K, right? And therefore therefore what? The cardinality of power set. The cardinality of power set of B, the number of elements in power set of B. By induction hypothesis, if cardinality of some set is K, then cardinality of its power set is 2 raised to K. This is true for K, right? That we are assuming. And here cardinality of B is K. So by induction hypothesis, cardinality of power set of B must be 2 raised to K. That is by induction hypothesis. Fine. So we have, what is power set of B? Power set of B is empty set, then all single elements, right? A2 and so on, AK. Then I will look at two element set, right? So A1, A2 and so on, A2, A3, then A1, A3, all possible two element sets, right? and then I will look at 3 element set and I will look at 4 element set, and at the end I will have all elements A1, A2, AK, K element set. So these are all subsets of B, right? This is the power set of B. So fine. So power set of B has 2 raised to K elements. That we are sure by induction hypothesis, because cardinality of B is K. Now, if so, from this, how will you get the power set of A? What is missing if you want to get power set of A, and if you compare power set of A and power set of B? What is missing? AK plus 1 is missing, right?
AK plus 1.
Right. So
AK
what I
plus
will, so if we combine AK plus 1 with every subset of B, right? That means combine AK plus 1 to this, AK plus 1 to this, AK plus 1 to this, right? So what we get, which sets we'll get if we combine AK plus 1 with phi? What I will get? AK plus 1, right? If I combine AK plus 1 with A1, what I will get? A1 AK plus 1.
AK plus 1.
Fine. So combine AK plus 1 with each element in the power set of B, each subset of B, right? So ultimately what I will get? A1, A2, A3, AK and
AK.
AK plus 1,
AK
because
plus
I am combining AK plus 1 with every element, right? So now power set of B is okay. These are power set of B is also the elements in power set of B, or sets in power set of B are also power elements in power set of B, or every subset of B is also subset of A, right? So no doubt, and therefore let me call this as set C. If I combine every AK plus 1 with every subset of B, I will get one more set C. Then what is cardinality of C? What is cardinality of C? How many elements are in C?
2 raised to K plus 1. 2
Exactly,
raised to K plus
because
1.
I am just taking same number of same sets from B. I am just attaching one more element.
2 raised to k.
Right. So 2 raised to K, the cardinality is K. So note that what is power set of A? Power set of A is power set of B union C. Am I right? Because if you collect all the subsets of B and all these new subsets, new sets which are in set C, right? If we combine this together, I will get power set of A. That means I will get all the subsets of A. Am I right?
Yes, sir.
Right? Because no subset of A is missed out, right? Because these are subsets of B, though these are also subsets of A. But what is the problem with power set of B? It does not include AK plus 1. Include them. So these are new sets, and these new sets which are in C are different from power set of B. The sets here and sets here are clearly different, because this set contains AK plus 1. Every member here contains AK plus 1, but no member here contains AK plus 1. So clearly these sets and these sets are different and distinct, and these are 2k 2 raised to k, these are 2k plus 2 raised to k, and these two together, power set of B and C together, will give us all the subsets of it, that you can check easily, right? So
So can you please explain how the cardinality of C is become 2 raised to k?
see, suppose these are subsets of B, these are in power set of B, right? Okay, now suppose this is one subset of B, this is one subset of B, this is another subset of B, and how many are subsets of B? How many are this? How many subsets of B? Suppose this is power set of B, and how many are these subsets? 2 raised to k. Is
2
it
raised to K.
Yes.
fine? Now suppose this is the first box. First box means first subset of B. This is second box, second subset of B. Now in this box I am putting one more element, AK plus 1. Already it is a subset of B, but I am putting one more element. I am again putting one more, adding one more element each. How many sets are these? Same. Number of sets is not going to change. Only thing is I am adding one element in each set, right? But the number of sets is not, number of boxes is not going to change, right? So in this box I am adding AK plus 1 and already the original elements are there. In this box, original box is this, right? But I am adding one more element, AK plus 1. So this box as it is, but its size is increased because I am adding one more element and so on. So after all, this is C. And how many boxes are new boxes? How many boxes are this?
Same.
Same, 2 raised to K,
Same.
right?
Yeah.
Right.
2 raised to K.
Right, and therefore cardinality of C is also 2 raised to K. Is it clear now?
Yes, sir. Thank you.
So very
Yes,
good.
sir.
Fine. And therefore, and these sets are disjoint, no element is repeated. Therefore, what is cardinality of power set of A? Is cardinality of power set of B plus cardinality of C. But how many elements are in power set of B? 2 raised to K. How many elements are in C? 2 raised to K. It is 2 times 2 raised to
2
K.
raised to K.
So the total is 2 raised
2
to K.
raised to K plus.
So that is what we wanted to prove. Thus, what we have proved, if cardinality of A is 2 raised to K plus 1, then cardinality of power set of A is 2 raised to K plus 1. Hence, the formula is true for n is equal to K. Therefore, the result is true for n is equal to K plus 1. Hence, by induction, cardinality of A is equal to n implies cardinality of power set of A is equal to 2 raised to n. Fine. So hence it is true for all n. This is true for all natural numbers.
Sir,
Yes.
so what you have written the last third line, thus if cardinality of A is equals to K plus 1.
Pardon?
Cardinality of A should be K plus 1.
Cardinality of
Oh,
A
sorry.
should be
Sorry. It should be K plus 1.
K
Here
plus
it's K plus 1. Right. Thank you. Okay. Okay. So the proof is clear now by induction. Right. So alternative proof is there. Suppose without induction means direct, cardinality of A is equal to n. Suppose A has n elements. Now, now I want to construct all subsets. So to construct all subsets of A, right? So I want to construct power set of A. That means I will try to construct all the subsets of A, and then I will put it in power set of A, and then I will count how many subsets I found, right? That is what the aim is. So first of all, I will what I will do, I will contain so the subsets containing 0 elements, subsets of A containing 0 elements, right? So first I will try to construct set having no elements. So how many are such subsets? 5, right? So there is only one such set. Am I right? Is it clear? First I will try to construct the set having 0 elements, so only empty set. And so how many empty sets are there? Only one, right? Then what is the next step? Right, so I will construct one element set. Right, so n element set, that means what I will do, suppose my set is A, B, C, then what I will first construct empty set, and then I will construct single element set, right, because these are subsets of A. Then next time I will construct two element set, A, B, B, C, right, so two element sets, then AC. Then
AC.
right, then I will construct three element set and so on, continue. Here only three elements, so there is only one three element set A, B, C. And so these are all the subsets of A, right? So same strategy, same procedure we can follow for n element set. So what I will do, I will construct one element set, right? But how many one element sets are there? How
N.
many?
3.
Right? So there are n one element set, right? Because you choose one element at a time. So by combination, n choose one. There are n choose one element set, right? Am I right? So there are n choose one because I have n elements. Out of n, I am choosing one at a time. And how many ways are choosing one at a time? N choose one. Correct? Fine. Then what is the next step? Construct
2 element set.
two element sets. And how many ways we can construct? There
N
are
into n minus 1.
And
n choose 2, right?
NC2.
N
and
c
choose
2
to
two element sets. So continue with this process. And ultimately in n step, what I will get are n plus 1 steps. What will be n plus first step? Last step, what will be? So n element sets.
NCL.
N element sets. And so there are n choose n element sets. Right, so n choose n, and so in total how many subset I found? So 0 element set plus 1 element sets plus 2 element sets plus 3 element sets, so in total we get what are 0 element set? 1 is n choose 0, right, plus 0 element set is only one element set n choose 1. How many 2 element sets? N choose 2
and
and
choose 2.
n choose n. So in total we get uh, these many sets. In total we get these many
2 raised
sets.
to n.
And we know that this sum of binomial coefficients is 2 raised to n. Why? Because if we expand 1 plus x to the power n in binomial expansion, it is 1 plus x, what is this? N choose 0 plus n choose 1 x plus n choose 2 x square and so on, n choose n x raised to n. This is binomial expansion of 1 plus x raised to n, and this binomial expansion is valid for every real number. So binomial expansion is valid for every real number, right? It is not special about any some x, so it is for every. In particular, if my x is equal to 1, right, if it is true for every x, whatever x you put, the equation holds, right? So therefore if I put x is equal to 1, then also it is true. So if x is equal to 1, then what is the left hand side of this expression? 1 plus 1 raised to n, that is 2 raised to n. And what is the right hand side? N choose 0 plus n choose 1 plus n choose n. This is the right hand side. And therefore, what is the sum of binomial coefficients? 2 raised to n. That is also clear. and thus there are how many? There are
2
n,
raised to n.
there are 2 raised to n subsets of A, right? And that is clear from this. So this is a proof where we don't need induction, right? For any, you choose any set having n elements, and then you can directly prove that it has 2 raised to n subsets. So that is by using binomial coefficients. Fine. Okay, so uh, now let A and B be two sets. Suppose A and B are any two sets, then the Cartesian product of A and B is denoted by A cross B, Cartesian product, and is defined as A cross B is a set of all pairs such that A belongs to A and B belongs to A belongs to A and B is from second set. So if we collect all such pairs, then that is A belongs to A and B belongs to B. Fine. So this is a set of all pairs. So thus Cartesian product of thus Cartesian product of A and B is the set of all ordered pairs A B whose first component is from A and the second component is from B. So pairs, order. So pairs are called as order pairs. Why order pairs? Due to some reason. So that we will see later on. So pairs, first component is from first set and second component is from second set. Then it is the set A cross B. So so what is ordered pair? So ordered pair is the pair AB is defined as the pair AB is defined as uh, A AB. Means what? So remember that pair AB is not same as BA, right? So note that pair AB is not same as BA, right? That we want to we should remember, because otherwise all many pairs will be equal. So two pairs, that is two pairs two pairs AB and CD are equal two pairs are equal if and only if their first components are equal and second components are equal. So two pairs are equal.
Sir,
So,
sir,
so yes,
sir, in above, why should we take not B in order pair?
why not take
B
which
in
B?
definition of order pair, we take only A.
Let me explain. Wait this. I will explain this also. Anyway, so when two pairs are equal, if the corresponding first component is same and the first component of this pair, that is order pair AB is same as order pair CD if and only if A is equal to C and B is equal to D. That means two pairs are equal if and only if the components are equal. And therefore, if we say AB is equal to CD, that means A is equal to B and B is equal to A. That means A and B are same, but that is not true in general. So that means AB is not same as B. Okay, so let's come to this. So how do we define order pair? So order pair is a set. Okay, let me put in this bracket and then order pair. So order pair AB is defined as the set. What is a set? Having two elements, right? So what is a set? It is a set of two sets. What are the sets? So first, one member of set is a one component which is present in both of the sets, and one member is another component which contains element which is in only one set, right? So remember that this set A is contained in set AB. So this is a smaller set and this is larger set, and therefore we call this as a first component and this as a second component of order pair. Okay, listen carefully. What is order pair AB? Order pair AB is a set of two sets, so in which one member of that set is a set which includes an element, single element A, which belongs to both of the sets, and another member is a set which contains one more element which is present in only that set, not present in the another set. Right, this is something logical or philosophical fact. You may find it difficult at this moment, but it is a set and there is some order. There is some order means what? It is a collection of two sets. What are two sets? One set is A, another set is AB, and how do we define the order? That means how to define which is the first component and which is the second component. If A is a subset of, if this set is a subset of this set, then this is the first component and this is the second component. So we define particular kind of order here, which is a smaller, or so that's why it is called as order. But at this moment, you may find it difficult to understand. We'll try to discuss this later on when we understand the relations, right? And then there is a partial order relation kind of thing, right? The order relation is there, but for simplicity, you just remember that what is order pair? It is a collection of two sets, right? And when we say that set, then in set there is nothing like order. If I write AB and this, in this case these two sets are equal, because in set, suppose I am saying set of all students in A division. Sometimes we put the students in roll number wise, or we put all the students in one class, nothing, and there is no roll number assigned, then still it is the same set of A division, right? If I put all the students in one class without any order, without any roll numbers, and suppose I put all the students in a row so that they are arranged, their seats are arranged according to the roll number, the same division, same set. Therefore, which member is first and which member is later on, which member is first and which member is second doesn't matter, right? As a set. But which, if this is order pair, then which is a first component and which is a second component? So that is what we have to mention, that there is a relation, order relation. So which is the first component? So this is a first component because this is a subset of this, right? So singleton A is a first component and this is second component. So what is the first component? The what is the element present in singleton, and what is the second component? So bigger set, because AB is a bigger set, the element in bigger set which is not in smaller set. So B is a bigger in this bigger set, B is a new member which is not in smaller set, so that is the second component. So in this way order pair is defined in general, right? Okay, so still you have
It
confusion?
means, sir,
Yes,
a singleton set is always the first component.
exactly. Singleton is the first component, and what is the second component? Second component is the element in larger set which is present in that set but not present in singleton. So B is the
Yes.
element which is present here but not here, that is a single component. Am I right? Okay,
Yes,
so
sir.
this is, and therefore either you write this or this.
Sir,
A, yes,
sir, order pair of AB is also as B.
no. What I said, B cannot be first component because first component must be present in both of the sets. First component must be there in both of the sets. So which is the first component which is present in both of the sets? What is the second component? The element which is present in only one set. Is it clear?
Thank you, sir. Thank you, sir.
Right. So this is order pair. Now you try to define order pair for three components. The same logic, and now you can define pairs in n components. That means the n tuples or the elements having n components. But at this moment we are interested in only order pairs having two components. Okay, then why there is a word order pair? You might have heard this word order pair. Have you heard this word before?
Yes, sir.
Yes, sir.
So why order? Because order is there because there is a something kind of smallerness and biggerness. That's why it is called as order pair. Right? Because order word is there without you did not bother about order word so far. Because order means what? What is our usual perception about order? Order, right? For example, you are in some institute, then the senior person, then junior person, then still junior person, there is order, right? So superior, inferior person, then superior person, then more superior person. So everywhere there is order, right? And therefore, right, so the set AB is a superior than set A because it is a bigger set, and that's why the pair AB is called as order pair, because the word coming from this kind of definition. Am I right? Is it clear?
Yes, sir.
Right, so very good. So that's why the pair is called as ordered pair. Fine. So now we were talking about Cartesian product of two sets. So what is the Cartesian product of two sets? The collection of ordered pairs. And since note that set AB and A is not same as set B and AB. Right, so these two sets are not equal. Am I right? These two
Yes,
sets
sir.
are
Yes,
not
sir.
equal. Oh,
Yes.
fine.
Yes.
But what is
Yes.
this set? What is this set? Order pair AB. And what is this set? What is this set? What is second set? What second set suggests? What is the first component?
BA.
B in
Remember
the
which
first.
B
Order
comma
pair
A.
BA.
A should be at first
BA.
position and A should be at second position, and that's why these two order pairs are not equal. Right? Fine.
Yes,
So
sir.
So now how will you write the order pair 3, 5? 3,
3, 5.
3
5.
comma 3 comma 5.
3, 5.
Very good. What is order pair 5, 3?
5, 5, comma 5, 3.
5,
Very
5,
good.
comma
Comma
3.
5 comma 3.
5, 3 or 3, 5, same thing, because as far as set is concerned, doesn't matter which set is first, which member is first and second, doesn't matter. Okay, so or 5, 3, 5 doesn't matter, because 3, 5 set is same as 5, 3 set. Anyway, so therefore these two order pairs you can understand as a order is there, and order comes from the there is order among these sets, so which is a superior set and which is inferior set. So the pairs are order pairs. Okay, very good. So let us work out some examples. Let A is
Sir,
equal to S.
sir, can we write above like 3, comma 5, comma 5, 3,
3.
comma 5, comma 5, 3, or 3, 5?
No, what 3 means? Where is the set notation? 3,
In the set,
3,
3, 3 is a set,
uh,
and then 5 is a set,
uh,
and then 3, comma 5.
3, 5. No, this is different thing now, because what I want, first component is a member which is present in all, right?
Huh.
So, and if you are saying 3 set, that means it is a 3 component pair. The 3 tuple, it is called as a 3 tuple. So for example, you know the such kind of elements A, B, C having 3 components. Okay, in this notation, how will you write it? First of all, I will try to write down it as, I will treat this as a first component and this as second component. So how will you write it?
Set A,
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 B,
and then set
comma
AB,
set
set
AB,
ABC.
ABC,
B,
then ABC.
right. First component present in all, second component present in 2, and third component is present in only 1. In that way we can write, right? Because this constitute these two first two sets constitute what? A comma B, and A comma B, right? So A comma B is A comma B is present in A comma B. Is there any alternative way? Just apply same logic. A comma B and A comma B comma C. Am I right? So what should be the first component? My first component present in
A,
both,
B.
A, comma B.
right? So first component should be A comma B, right? And what is the second component which is present in
A,
C,
B, C.
C.
right? And
C,
ultimately
C.
it is A comma B comma C, right? So whenever I say 3 elements, 3 sets, that means it is a 3 tuple or 3 components, right? Okay, now you generalize, try to generalize this. Not right now, it is not very necessary. We are interested in the order pair having 2 components. Anyway, A is equal to this and B is equal to A, B, C. Then what is set? A cross B. So first, it is a collection of order pairs, right? And therefore it is, as it is a collection of order pairs, the first component must be coming from A, right? 1,
1, A.
1 comma B,
1, comma A.
1 comma C, right? So first
C.
component,
Yeah.
Hmm.
2nd
2,
component
comma A.
from
2, comma
2 comma A, 2
2,
comma
comma
B,
C.
2 comma
A,
C.
B, 2,
comma B, 2 comma C. Very good, fine. So these are elements in A cross B. Now how many elements are there in A cross B? Right, so
6
it's
elements.
6 and it is 2
6
into,
elements.
right? So 2 is number of elements in A and 3 is number of elements in B, right? So the
Yes.
number of elements in A cross B is the product of number of elements in A and number of elements in B, right? So you prove it. So prove that if cardinality of A is equal to n and cardinality of B is equal to m, then the cardinality of A cross B is m into n.
M into N.
Right. Very fine. So uh, uh, this is homework. You think about it and apply induction. You fix. So how to apply induction? Hint: fix n and apply induction on m. Fix n or m, no problem. Either you fix n or fix m. Choose particular n, whatever, fix n, and then what only varies, m varies. So apply induction on m, and then that you can say that it is true for all m and n. This is called as a double induction, right? So fix n and apply induction on m. So
Sir,
yes,
we can prove this same thing without applying induction, right?
yeah, there are lots of ways, many ways. You can think about it, and if some people have different ways in practical sessions, while we conduct practical session, we can discuss such type of things, various ways to prove same thing, right? Okay, fine. Well, so suppose A is equal to 1, 2, 3, then what is A cross? What is A cross A?
1 comma 1.
1 comma 1,
One, one,
1
one,
comma
two,
1 1
2
1
comma
2 1 3.
Uh,
1, 2, 1, 3.
1 1
1,
Again,
1 2
2, 1,
1, 2,
1
1
3
3,
2 1
1,
2
3.
2 3
2
1,
2,
1
1, 2, 2, 2,
3.
3.
2 1
3 1
2
3
2
2
2,
3 3
3,
3, 1,
1,
2
1
3
3,
3,
3,
2,
2, 3,
3, 3.
3,
Very
3.
good.
3 3.
Fine. So these are elements. And remember that 1, 2 is not same as 2, 1. And that why they not same? Because by definition of order pair, it is clear. 1, 2 is not same as 2, comma 1. Fine. And therefore, all these are distinct pairs, right? And this has 3 into 3, 9 elements. That is clear from previous formula. So A cross B. Now you understand clearly the set A cross B. Okay, so let me tell you one more example. Suppose A is equal to what I should take set of all students from A division, right? And B is equal to the set of what is correct, set of books, distinct books, distinct books. Suppose in A division, suppose there are 100 students, and suppose we have some books, whatever books we have. So suppose we have let us say 100 books, no problem, right? Then what is A cross B? What is A cross B? I will
10,000.
10,000.
that The number is okay,
Yes,
number is
10,000.
fine. But what are the elements? So student 1 or student 1 and book 1. I am pairing student 1.
Yes,
So,
one B1
right,
like that.
A1, B1, A1, B1. So A1 is a student and B1 is a book. Right, A1,
Yes.
B2. So A1 is a student and B2 is a book. In that way, I can pair students and books. Students and books. So, but if I put a condition that, so in this case, what is happening actually, I am assigning same student with different books. I am assigning same student with different books because every student can access any book in the library. Suppose there are 100 books in library and there are 100 students. Not necessarily 100 books, but for simplicity, let us say this. I am assigning student with book. So this student can access this book. A1 can access second book. A1 has access to each and every book. Similarly, A2 can access the second book and so on. Right. So this is a pairing and student is paired with book. Now, if I put a condition, so if there is a condition that, so there is a condition that uh, one student can access, can uh, issue only one book at a time. Right. So one student can issue only one book at a time, not all the books at a time, because then others will not get books, right? Then what I will get?
A cross B will be 100, each student with one book.
So A1 can access suppose 10th book, right? A2 can access suppose second book. A3 can issue suppose fourth book, and so on. So how many pairs I will get?
100.
Right. So
100.
I will get
100%.
100 pairs.
100.
And what is what is the speciality of this set? So this is a subset of A cross B. Am I right? This is subset of
Yes.
A
Yes.
cross.
Yes.
And what is the speciality of this book? This set. So the second component is not repeating. Second component is not going to repeat. In A cross B, not second. First component is not going to repeat, as well as second
But
component is also not going to repeat. But in
Component
this,
is not.
right, in this A1 may repeat or B1 may repeat, because while you pair A2 with B1, then B1 repeated, right? I can pair A2 with B2.
Yes.
So here all components are repeated, but here neither first component is repeated nor second component. So A1 is appeared once, it is not appeared again. B10 is appeared once, it is not appeared again. So every component is appeared only once. So this is a subset of A cross B, right? But this is not equal to A cross B. It is a strictly proper subset. Am I right?
Yes, sir.
Yes.
Fine.
Yes.
yes, sir.
Now we are interested in subsets of Cartesian product of two sets, right? Because Cartesian product is something a larger thing, and in some sense that creates a problem, lots of problems. Right. So that's why we want something. We are interested in smaller sets in which are very useful in our day-to-day life. So that is our next definition. So relation. Suppose A and B are two sets. A relation from A to B, right? When I say A to B means I am assuming first set to be A, second set to be B. So relation from A to B is a subset of of A cross B. Right. So what is the relation? You choose any subset of A cross B. It is a subset. It is a relation from A to B. Right. So for example, suppose I take A is equal to 1 comma 2, A is equal to A B C. Then you know what is A cross B by our definition. A cross B is all pairs. Then I will take R1 1 comma A, 1 comma 2, 1 comma B, and 2 comma C. So is it a subset of A cross B? Is it a subset of A
Yes,
cross B?
sir.
Yes,
Yes.
sir.
Yes.
Yes,
So
sir.
now you choose any subset of A cross B, it is a relation. Relation means what? Then we say that so R1 is a relation, and we say that 1 is related to A with respect to this relation R1. What is the meaning of 1 comma A? So that is pair 1 comma A is in this relation R1 means what? It is equivalent to saying that 1 is related to A, right? The pair is in R1 in this relation. The pair 1 comma A is in the relation R1 means with respect to this relation 1 is related with. That is what the meaning of this. Similarly, 1 is related to B, 2 is related to C, but 1 is not related to C with respect to this relation because this is a very special kind of relation we have defined. Right, A cross B is a something different, but I am choosing particular subsets which is a relation. So for example, uh, uh, you choose another subset. I am choosing subset means I am defining some relation. I am choosing particular kind of relation. So I have chosen this set means with respect to my this kind relation, one is related to A, one is related to B, and two is related to C. Nothing else. That means one is not related to C, or two is not related to A, two is not related to B with respect to this relation. Suppose I select R2. Suppose I select R2 1 comma A and 2 comma B. Right. So clearly this is a subset of A cross B. So with respect to this relation, one is related to A and two is related to B. I don't want anything else. Right. So this is what the relation. So next time we'll see more detail about relation, and so we'll see
Sir,
some. Yes.
sir, can you please explain this again?
Which?
Sir, this example.
Okay. So uh, I want to define relation from A to B. Of course, it is a subset of A cross B, but at moment forget about A cross B. So how I am going to define relation from? Suppose A is set of girls G1, G2, and B set of boys B1 and B2, and I want to define a relation that key the girl is related to boy B1 if G1 is a sister of boy B1, right? Otherwise not. If girl is a sister of boy B, then they are in relation. Which relation? The sister relation. So the same kind of thing is here. The meaning is our usual meaning. What is the meaning of this? One is related to A. With respect to I am saying that one is related to A, one is related to B, and two is related. This is my relation. That is what I am defined. And I am defining that key two is not related to A or two is not related to B. This is my relation. I am imposing on these two sets. I'm imposing on the members of these sets. Right. Okay, this is one kind of relation. There could be another relation. Ki G is a related to boy, girl is related to boy if they are friends of each other, or G is related to boy if there could be another nephew or cousin type of relation, whatever, doesn't matter. So this is another relation. One is related to B, two is related to B. 1 is related to A, 2 is related. This is my relation I am defining on members of set A. And it is not necessary that every girl is sister of every boy in B. Not necessary. It is just collection of girls and this is collection of boys. Some girls are sisters of some boys and some girls may not be. So therefore, not necessary all members of A cross B are in relation. All right. Is it clear?
Yes, sir. Thank you.
Okay. So next time we'll see discuss about it more, and then we'll see some real life problems also, so that you can understand.
Thank you, sir.
Okay. Okay. Let's try to stop here. Then we'll continue this.
Hello, sir.